Thank you everyone for your time today, and we're going to go over a few of the new structural requirements and some of the highlights of the 2014 New York City Codes as far as structure is concerned. Again, like the rest of the codes, the 2009, these codes are based on the 2009 IBC, and really the structural committee did a tremendous job putting all of the requirements together, going through everything, and incorporating a lot of good New York City specific improvements and making some big adjustments that I think are good improvements to the code. It was a very large committee that had a very large task, and I think they did a tremendous job under the chair, Ramon Gilsands, and the co-chair, Anya Brazel, both well-known practitioners in the area here. And we'll go over some of the highlights of what they were able to accomplish. We can't, excuse me, get into all of the details of everything that they were able to do, but hopefully I can give you a good idea of some of the improvements that they've made and some of the changes that they've made from the 2008 code. The basic code, again, is 2009 IBC based, which the 2009 IBC references ACEC 7, which is, I think, minimum design loads for buildings and other structures. That's our primary structural reference standard. The 2009 IBC references the 05 edition, but here in New York, of course, we had to make some improvements, so we reference both the 05 edition and in some cases the 2010 edition to bring us more in line with, in some cases, the 2012 IBC. These are some pretty significant improvements that we'll talk about a little bit today. And then throughout the other structural design chapters, the material design chapters, the additions of the reference standards were updated. I think James touched base on that earlier, that, why do we need to keep updating our code? It's because, technology doesn't stand still. The design methodologies and materials available, are changing on an ever-changing basis, and our codes need to keep pace with them so that we can continue to allow the best practices internationally here. So, we have a 2008 code, but in some cases we're referencing 2002 or earlier editions of structural design standards. So before you knew it, we were already more than 10 years behind on some of these design standards. So again, ACEC 7, this is the big one as far as structural engineers are concerned. This is where your basic load requirements come from. And here's just a little summary table to show you where the different load requirements came from. Now again, we have two different editions of the same standard referenced in the 2014 New York City Building Code. If you see here, if I can get the arrow going, ACEC 7 2005 is indicated in the text as ACEC 7, and it's referenced for the vast majority of the loads that are referenced in the code. Dead, live, snow, etc., it's all there. ACEC 7 2010, which is, you're going to see indicated in the text with a little -10 after it, is adopted primarily for earthquake loads. That was a significant improvement that came along with the later edition of ACEC 710. There was some structural savings and some structural safety improvements in there that our committee thought needed to be taken advantage of, and they went the extra step to incorporate those requirements here. And then, of course, we have our New York City specific requirements. The prior code buildings that James mentioned are in Chapter 16, so all of those special provisions for prior code buildings are located in Chapter 16, and the structural integrity design requirements, which were New York City specific design improvements based on other national standards for structural integrity and progressive collapse prevention, but they are New York City specific as far as building codes are concerned, and they're also in Chapter 16. There are some sprinkled throughout the other chapters as well, but the primary ones are in 16. Okay. Construction documents. There were some minor changes and improvements to the requirements for construction documents. In general, just coordinating with the latest edition of the reference standards themselves, but just to also bring it back around, there are also construction document requirements in Chapter 1 of the Building Code. BC 106.7 of the 2008 codes, and now under the 2014 codes, 107.7 have some good requirements that we really shouldn't neglect. They have some requirements such as, the column schedule and column loads being shown on the column schedule, things of that nature. Those are sometimes skipped over, and they need to be incorporated. A little bit more on Chapter 1 of the Building Code. I know we're in structural design, but this is definitely relevant to structural construction documents. The requirements for earthwork plans in the now BC 107.8 have been expanded and clarified to talk about what types of plans and what information is required to be shown depending on what type of work is being performed. Those earthwork plans will be required. And also, the requirement to post live loads in certain occupancies and with loads over a certain specified amount. That used to be in Chapter 16 in the 2008 Code. It's been around. We've had similar requirements since the 38 Code and probably earlier. Those requirements have now been moved from Chapter 16 as they're more an administrative requirement to have yet another sign that need to be moved to Title 28, the administrative provisions of the 2014 Code. A little more on some new structural design provisions that were added by our committee, and these are primarily committee enhancements. Superimposed dead loads. When a structural design incorporates the use of superimposed dead loads as part of the design, then those superimposed dead loads have to be indicated on the construction documents as part of the 2014 Code. There are no superimposed dead loads specifically called out in the code, so that's not something that's being done. But if the superimposed dead loads are used as part of the design, then they need to be indicated on the construction documents themselves. Also, the machinery loading was clarified, basically for equipment and other machinery, maybe high-density filing, things of that nature. The special loads, they have to be identified on the plans when they exceed the minimum specified loads for that particular area that's called out in the building code. So if you're designing a floor to support some type of specialized equipment that exceeds the minimum specified live loads in Chapter 16 for equipment rooms, mechanical equipment rooms, then you have to identify that on the plans with what type of load, how much load were you considering, and what area, and a description of the equipment. We're going under a slight change in terminology as far as structural design is concerned. As part of the 2008 Code, we adopted a term called the Structural Occupancy Category, which is used in ASCE 705 and earlier. They actually call it Occupancy Category. We added structural to it here in New York to distinguish it from occupancy classification, because we can't have terms that sound that similar. We'll be talking about the wrong requirements there if we're mixing up those two terms. So we added structural just to be clear, but ASCE 710 got the hint, and they changed it from occupancy category to risk category. Both terms have the same definition, a category used to determine structural requirements, basically, and it's based on the occupancy of the structure itself and the use of the structure. So wherever you see the term structural occupancy category, that's based on the IBC 09 text, and wherever you see risk category, it's based on the IBC 2012 requirements in ASCE 710. So if you go back to my earlier slide, it's primarily earthquake requirements that we're looking at with regards to risk category and when that term is used. But going forward, future editions of the New York City Building Code would end up having the term risk category, because that's the direction that nationally the industry is going in. This is just a quick summary table of, just to give you a brief rundown. Many of you know this already. The breakdown of what is a structural occupancy category or risk category, depending on excuse me, which edition of the standard you're using. Most buildings fall into Category 2, which has the great definition of buildings not listed in Categories 1, 3, and 4. Category 1 is low hazard to human life in the event of failure. This is barns, etc., things of that nature. Category 3 are buildings with a substantial hazard to human life in the event of failure. This is buildings with a significant type of occupancy where there is a substantial hazard to many lives, or in particular based on the use of the building. And Category 4 is what's termed essential facilities. These are buildings that if a Category 3 building is of importance, Category 4 buildings are of slightly greater importance because they may affect an entire community. This is fire and police stations, emergency shelters, things of that nature. And the structural requirements, as well as flood design requirements that you're going to hear about a little later, they all vary based on the the structural occupancy category or risk category. Again, here, the change here is in the terminology of whether it's structural occupancy or risk. And here, just a quick little summary table for you, whether or not you're using, depending on which load you're discussing, which term you're using. And again, risk category applies to ASC 710 and earthquake loading. All the others refer to the structural occupancy category. Okay. Now, one change that we did adopt to align ourselves with the IBC and with ASCE 7 was the inclusion of buildings with an occupancy load greater than 5,000 into Category 3. Under the 2008 New York City Code, this could have been considered a Category 2 building. Now you're going to have to consider these as a Category 3 building. Just some quick rundown examples to give you an idea of what that may mean. So we're talking about greater than 500,000 square feet of business in a particular building, greater than 1 million square feet of residential area, or any other combination of occupancies that totals up with an occupant load of greater than 5,000. This would move you from the Category 2 to Category 3, and all the load design and other implications that come with it. And again, this is meeting what's in the national standard right now. Okay. The committee felt it would be a good clarification to provide a summary table of the importance factors that get applied to the different types of loading depending on the occupancy category. So this is a New York City modification that I think helps practitioners in identifying what the particular importance factor to be applied to the different design loads is. And you can see here that, for example, the change from a Category 2 to a Category 3 could mean a 10% increase in snow load or a 25% increase in seismic load, depending on what you're particularly designing for. So these are things to be on the lookout for. Okay. Some of the alternative load combinations based on allowable stress design that have been around for quite a long time that are not greatly in use, but were still somewhat in use. The committee got together and came to consensus to remove them. They're no longer really supported by the national standards. They're just around in older legacy codes. So they've chosen to remove them from the New York City codes. And they, as part of our further enhancements, there were specific flood load combinations provided for in Chapter 16 to provide some clarity. There's the load combinations themselves you could have found previously by going through the reference standard and the building code, whether it's the IBC or the New York City Code. You could have combined them all together to come up with the appropriate load combinations, but the committee got together and put them in directly for you. And you'll see there's also specific mention of a new type of flood zone called a coastal A zone. You'll be hearing more about that when Joe Ackroyd, my colleague, starts talking about the applicability of coastal A zones during his talk. Right now, it's a new requirement here in New York. It's not necessarily applicable just yet, but our code does reference it at this point. Sidewalk live loads have been revised. This is a big change. This is something that we have historically had in New York City, the 600 pound per square foot sidewalk live load. That has been reduced after our committee did a lot of research on the types of equipment and vehicles that emergency service personnel use and what are the live load requirements in other municipalities and areas. That was changed from 600 pounds per square foot down to 300 pounds per square foot. But what they did find was that we were missing some requirements for concentrated load cases from either wheel loads or from the outrigger posts that some of these emergency service vehicles use. So you're now going to have to consider 2 concentrated load cases, one of 8,000 pounds on a 20 square inch area and a 20,000 pound load on an area 20 inches by 10 inches. So there's some modification to that, but this, in some cases where you have framed areas that will be able to support vehicular loading, this will provide some greatly needed updating of what our requirements are. Okay? As James mentioned earlier, there have been updates to the loading requirements for handrails and guards, in particular with regards to the intermediate rail loading requirements that are in Chapter 16. And this is incorporating some of the requirements that the department published originally in 2011 in a Buildings Bulletin. Buildings Bulletin 2011 number 17. They're now incorporated into Chapter 16 directly, so we no longer need to go find the memo from however many years ago to remember how to design the building. It's going to be right in the code for you. And as part of the update to the IBC, we're getting also their enhancements, including special provisions for how to design fabric partitions and the framework that supports them. Okay. Wind loading. Wind loading was also updated in our 2014 code. We are based on ASC 705 with a local New York City wind study to get our specific wind speed. We've maintained the 98 mile per hour design wind load based on a 3-second gust value, but we have revised exposure categories and maps that go along with them so that you can identify what your exposure category is depending on the area. These exposure categories are primarily based on your proximity to the coastline. Exposure category A, which was the general picture in older editions of ASE 7 was of the Empire State Building, I believe, and its surrounding topography. That is no longer applicable as far as a design parameter, and we have now added exposure D to match what's in ASE 7. And basically, you can go to these New York City specific maps, which our local committee put together, and I call them a local committee because it's our local practitioners, but it was over 40 practitioners and many guest experts in some cases from around the world came in to help put these requirements together to make sure that we had the latest and greatest. And one thing that we thought as a department felt more appropriate to present here, but it's not exactly in Chapter 16, it's in Chapter 15, but it's a wind-based structural enhancement to safety, is the prohibition of gravel ballasted roofs going forward. This is an enhancement that we're getting as part of our adoption of the IBC text. The 2009 IBC has a prohibition on gravel ballasted roofs in all hurricane-prone regions, and New York City, as we've unfortunately come to know, is a hurricane-prone region. And the text in Chapter 15 in the text says gravel ballasted roofs, aggregates, stone, etc. are not permitted as a roof covering going forward. Now that may also apply depending on how much re-roofing you're doing. So going forward, gravel ballasted roofs will no longer be permitted as a new construction material. And if you have an existing one, if you are re-roofing, you may be required to replace it with something else, depending on the scope of work you're performing. And this comes mainly as a recommendation from the National Council of Structural Engineering Associations. They have gone through and done post-hurricane assessments in many countries, not just the US, but many locations, and they've seen the impact that such small particles can make, as they can end up being projectiles that cause damage downwind of the structures that have the gravel ballasted roofs. Okay. Now, post-Hurricane Sandy, there was a task force formed under the Urban Green Council called the Buildings Resiliency Task Force, and they had a number of recommendations which you'll hear about later, one of which goes into effect October 1 as a separate local law to what was done in the 2014 codes, but goes into effect at the same time, and that was to protect specific structures from wind-borne debris. This requirement will affect structural occupancy category 3 buildings that are in exposure category D, where they have glazing that encloses assembly spaces for 300 or more occupants, or their areas of in-place shelter, and structural occupancy category 4 buildings in either exposure category C or D. Basically, these structures will have to have impact-resistant glazing to protect the occupants from wind-borne debris and to protect the building envelope itself from wind-borne debris and to keep its integrity during a wind event. So this impact-resistant glazing has to be provided up to 60 feet above grade and up to 30 feet above adjacent aggregate surface roofs within 1,500 feet of the building. There are also requirements now for, again, this is the same protection from wind-borne debris, for impact-resistant louvers up to 30 feet above grade, as well as impact-resistant garage doors. So the idea is to keep the envelope intact during these high wind events, given that you could have large-scale and small-scale debris flying around. Losing a window in those category 3 or category 4 buildings could be quite catastrophic and have a huge impact on the structure. A very significant change that was made by the Code Committee was the inclusion of loads on temporary structures and how to address them. This is something that we're probably one of the first jurisdictions to adopt something like this, but we have provisions for structural design and loading requirements for these temporary structures used either during construction or temporary installations that are used as an alternate type of occupancy in some cases. So the provisions there are special. They're based on the duration of the installation. So the installations that are governed by Chapter 33 as far as temporary installations used during construction, they're allowed for up to 1 year, and the other types of temporary structures that are covered by Chapter 31 of the Building Code would be 90 days. Now, there are time extensions permitted in the text of 1618, and it's something to read as far as how to go about doing this, but it would require follow-up evaluation of the current site conditions and the installation itself. Now, basically, these structures are going to be required to comply with the load requirements for new construction, with some exceptions that are permitted for environmental load reduction. Some examples of that are wind. You can apply a 0.8 factor to the wind applied to these temporary structures. And for seismic, you can replace it with a 2% 2% lateral load applied to the structure rather than evaluate them for seismic loading. Now, there are other environmental load allowances permitted in the text. So, for example, if something is only going to be installed in the summer months, it's only going to be installed, let's say, at the Memorial Day and taken down Labor Day, and in the design professional's opinion, snow loading was not to be considered in the design. That's something that we would consider. So the text allows for something like that. Okay, but if you are going to take advantage of these environmental load reductions, then you're going to be required to provide an emergency action plan to deal with what happens when we do get the wind event, snow event, rain event, flood event, etc. that you're taking a reduction for, as well as if you're going to be asking for a time extension for your temporary installation. As part of that, we're going to ask for mitigation measures that can be reliably implemented in 1 day or less to address the situation. Some of these mitigation measures could be take down the structure. Other methods could be, provide additional bracing and structural support to account for the increased loading. And things to consider would be the prevention of wind-borne debris and additional monitoring to make sure that, as your wind speed is picking up, that you are appropriately monitoring and taking the appropriate action at the right time given the situation. Okay. Earthquake loads. Again, we've touched on this a little bit going so far. For new construction, we're going to be based on ASE 710, and the text of the 2012 IBC has been incorporated where appropriate into the 2014 Building Code. This is all in section 1613. I believe earthquake requirements were previously spread out between 1613 all the way through 1623. Chapter 16 has gotten a lot shorter. All earthquake loading requirements now in 1613, as a lot of the text has now been moved into the reference standard. So you're just referencing ASE 710 for a lot of your design parameters. Now again, we have our own New York City specific acceleration parameters, S sub S and S sub 1, and they are different, I want to point out, from New York State. This map here is, what appears in the New York State Code for the design acceleration parameters. New York State adopted their most recent code before ASE 710 was completed, is my understanding, and they adopted a map that's different than what's in ASE 710. It's similar, it's the basis for what's in ASE 710, but it is different. So our design values in the New York City Code, the upcoming New York City Code, will be different. So you have to check section 1613 for the appropriate values here. And ASE 7 underwent a design concept change where they are now going based on a risk-based design for what is the risk of collapse during an earthquake. And they have that incorporated throughout their mapping parameters and their design parameters completely. So that's why our committee felt that this was a big advancement. In some cases, it could be a cost savings. In other cases, it adds safety as far as, let's say, for example, liquefaction analysis, which you're going to hear about later. There are some enhancements there. So this is something that's going to vary from site to site, but our committee felt it was important enough to go forward and adopt this right now without waiting till the next edition of the code. Now, again, seismic design category, this is something that's just going to vary based on your site profile and your occupancy, the risk category. Here's just a simple breakdown of what seismic design categories you might get depending on the site class and the risk category. This, you'll notice, we now have the capability, if you have a building located on site class A, of getting seismic design category A. So that's a big change. Previously, under the 2008 code, the lowest risk category or seismic design category that you could attain was B. So there are some improvements here as far as from a cost perspective. Yeah. Okay. Structural separations was a topic that was debated greatly. This is the requirement to provide a joint in between two adjoining buildings to prevent pounding should we have an earthquake event. Our committee worked on this greatly, and again, they reiterated some of these requirements, but basically 1 inch per 50 feet of height is the required separation between new construction, and the separation is required at the property line, not just to the adjacent construction. I know there was some older PPNs that referenced who builds their foundation first. This is not the case. This is to the property line. This is how it's been since the 2008 code, but this still keeps coming up as a question. Smaller separations are permitted by analysis. So if, for example, someone can prove that their structure is not going to move as much during an earthquake event, then we will gladly consider it for a smaller than required separation. The gaps between the structures will require covers. There was an old PPN on dealing with covers. That PPN, those requirements have now been folded into the code to tell you exactly what the requirements for the cover are, including live load if the gap is wide enough. Okay. Now, if the adjacent structure next to the new construction is an unreinforced masonry structure, which an evaluation of that structure can quickly identify, then the gap will be required to be filled. Part of the reason for that is the committee felt, and this is something the department has seen as well, that when a gap is left again between new construction and sometimes these unreinforced masonry structures, that the unreinforced masonry structure sometimes tends to move into the gap. While it definitely is undesirable and an unintended consequence, the intent here is to fill the gap with something that has some rigidity. You see stiffness values required here. This will hopefully keep the adjacent structure in its place, but while maintaining the gap so that should that structure eventually be torn down and rebuilt, the gap will be, you can just remove the compressible film material and rebuild a new structure. Now, there's also a reference here that any party walls that are exposed during new construction have to be made secure by the party responsible for the new construction. This is something that, older building designs had these party walls in place, and now there's a new building going up that was not planning on taking advantage of that party wall any longer as a structural matter. But before putting up the new building, you have to plan for what are you going to do with that wall. It is part one owners and part the other owners, but that wall needs to be structurally braced. And there have been some situations where neither owner intended on laterally bracing that wall, which may mean you may have a 6-story unbraced, unreinforced masonry wall in place unless somebody does something about it. The code now clearly points out that the party doing the new construction has to address this. Okay. Structural integrity provisions. The structural committee expanded the definition of what a key element is to include. Previously, it was vertical elements supporting 3 or more than 3 stories, I think was what ended up being triggered as a key element. Now, you have elements that are supporting a tributary area greater than 3,000 square feet on a single level to cover horizontal elements that support a large load on a horizontal scale as opposed to a vertical scale. There are also new requirements for explosion prevention that coordinate with the fuel gas code and the fire code with regards to high pressure gas installations. The key element analysis triggers have been expanded. So all structural occupancy category 4 buildings are going to be required to undergo key element analysis. Previously, I believe the trigger was based on the size of the framed area. Now it's regardless of the size of the framed area. And buildings with 3,000 or more occupants in one area are going to be required to undergo a key element analysis. That would pick up some of the larger stadiums. And there was also a clarification with regards to walls greater than 10 feet in length as far as the key element analysis. Thank you. Excuse me one moment. How am I doing on time? Okay. At the same time, this is again a 2008 code enhancement that was expanded. The peer review, the structural peer review requirements were expanded, similar to what was done in key element analysis, but not exactly the same. Buildings with 3,000 or more occupants were added to the peer review trigger, but you'll notice the category 4 buildings were not added to the peer review trigger. Okay. And the same clarification with regards to walls greater than 10 feet in length not being considered key elements came into play. Okay. Some enhancements in Chapter 19, reinforced concrete design. Here, the committee decided to, again, adopt 2012 requirements for reinforced concrete design. So we differ here from the IBC 09. We've adopted 318-2011 to make sure that we've gotten some of the latest enhancements to reinforced concrete design. And you'll see things like mention of new materials such as insulated concrete formwork is directly addressed in the code for the first time. And the particular reference standard that you design ICF to. The committee also made modifications beyond what ACI has done and what IBC has done. They increased the strength requirements for Group R occupancies. This is the minimum strength that was specified as far as durability was concerned. They also increased the amount of fly ash and other pozzolans that you're permitted to use when exposed to de-icing chemicals. This would allow greater recycled content to be used in concrete, and is a recommendation of the Green Codes Task Force, the former mayor's Green Codes Task Force. Okay. Concrete mix designs, everybody's favorite topic and favorite form, the TR3. Where's my TR3 is the usual question at sign-off of you have to bring the TR3 form down to get your TCO. The TR3, those requirements are still roughly the same. Can be done by either field experience or trial mixtures. The testing has to be done by a licensed lab. The change here was that the length of time that test results would still be acceptable to the department as far as basing a mixed design on them has been changed from 12 months to 24 months. So test results are acceptable for use as supporting a TR3 for a longer period of time. This is something that ACI changed and we've adopted along with them. The code also provides minimum criteria for how to evaluate when materials are the same, as far as evaluating whether or not prior test records can be used. And it's based on what type of material. Is it cementitious material, aggregates, or the admixtures themselves? What are the criteria that you can use to evaluate the different materials? And also field changes, what field changes can be made. Some of these requirements were in a buildings bulletin previously. They've been now incorporated right into the code. So some changes can be performed as says, where some material substitutions or changes can be made, modifications can be made to the quantities without the requirement of new tests. Others will require additional testing. Our code now talks about field changes directly in the code rather than, I think it's Buildings Bulletin 2010 number 18. I think now we can fold those requirements, we folded those requirements directly into the code so that the general complaint that we hear at the department is that the testing lab or special inspection agency at the job site is not aware that you can make some of these field changes which are in this memo. Now it's right there in the code for everyone to see. The committee also made some enhancements with the advent and the greater use of high-strength concrete greater than 7,000 PSI. I still come from the days when, practicing, you had to write 5,950 PSI as your design strength on the drawings because nobody wanted to touch 6,000 PSI or higher. These days, you can easily see on many high-rise buildings 8,000, 10,000, 12,000 PSI being used. But now, with that, we've found the committee brought up the point of thermal control, so that way your cylinder test will more closely align with what the in-place strength actually is. Contractors are going to be required to provide a thermal control plan for how they're going to keep the temperature of the concrete in the right tolerance range. It has to be submitted by the permit holder to the PE or RA who filed the structural plans. It's going to be required at a minimum for concrete with strengths greater than 8,000 PSI, equal to or greater than 8,000 PSI, and for elements with a minimum thickness of 36 inches. And as part of this plan, somebody's going to have to monitor it. So there's going to be a testing and monitoring requirement that goes into effect that's going to monitor how is the temperature actually being maintained at the job site for a minimum of 7 days. A requirement that's not new to ACI but is new here in New York is we're adopting for the first time the requirements of 318 section 5.4 that allows basically the determination of what the concrete mix design would be without test results, but basing it based on past experience and just general professional judgment of the people involved. This would now be allowed for the first time, but it comes with caveats. It wouldn't be permitted for any concrete greater than 5,000 PSI in strength, so it's got that cap. It wouldn't be permitted for any structural concrete, any load-carrying concrete greater than 50 cubic yards on the project. So again, we're talking small projects here, and you can use it for non-structural. You can't use it for anything where the exposure to the elements and de-icing chemicals would be severe enough to cause degradation of the concrete a lot faster, where you would want some kind of testing and proportioning, test results to back up the testing and proportioning here. But this is something that's new, this is something that's permitted nationwide, and we're adopting it for the first time here in New York. Okay. Anchorage to concrete design based on ACI 318 Appendix D. One of the changes here is the installation of adhesive anchors in certain instances, basically from the horizontal position to the inclined vertical to completely vertical, has to be done by certified concrete installers. The ACI provides a certified installer program nationwide, and they go through this on a regular basis. The courses are available, but this is going to be required going forward as part of the 2014 code. I've been told here I need to speed up greatly, so I'm going to do that right now. There are new requirements for Shotcrete, including certified Shotcrete installers be used when Shotcrete is used for concrete installation. There's design, the formwork design requirements a little bit on Chapter 33 has been expanded here. Formwork design is the instances where formwork design drawings are going to be required to be provided by the contractor. Signed and sealed drawings provided by the contractor, someone working for the contractor, need to be provided, have been expanded in Chapter 33 to basically encompass many more instances than what was previously required. And as a follow-up to that, there's also going to be a required formwork observation, periodic visits to the site by the formwork designer or someone under their supervision, either another professional or someone working under that professional supervision, retained by the formwork designer to make sure that the formwork design is being implemented. Chapter 21, some basic highlights here. We're updating to the 2009 IBC requirements for the most part, and it's incorporated some new materials such as autoclaved aerated concrete masonry units. Some updates to the construction document requirements. These are new, but they're basically things that were in the national reference standard that have now been moved into the text of the code so that they're more clearly shown to everyone and they're not in the other book that you got to buy. Masonry construction bracing. This is something that our code committee expanded on, but is a current requirement right now. Masonry contractors are required to provide a bracing plan for masonry walls under construction, but it's in the masonry standard. Doesn't excuse anybody from not doing it, but to bring it more to light and to bring it more up front and to bring up the discussion earlier, the contractor is required to provide the bracing plan, and that's called out directly in our code. And the plan has to be maintained on site. Okay. Chapter 22, again, updates to the national standards. I think we're going to the 2007 editions of the cold form steel standards, and I believe it's the 2008 edition of AISC 360. So we're catching up to where the nationwide everyone is going as far as steel design. There's some requirements in the plans themselves for steel joist drawings that are expanded steel joist placement plans as far as which joists are being placed where, how they're to be placed, and that they have to be signed and sealed. And again, another friendly reminder from the OA code, and in some cases from local law 26 of 04, that open web steel joists are prohibited in high-rise buildings. Okay, and last but definitely not least, wood. We've updated to the 2009 IBC and the 2005 edition of the reference standards there, and they are similar to the steel joist placement plans. You have requirements for wood truss drawings and wood truss placement plans that must be maintained on site and provided by the manufacturer. And with that, I thank you for your time.